All right, let's get started. So today's our first true 116 topic, at least in my opinion. We've had some memory diagram stuff, which was new for most of you, but we are adding that content into 115 starting next semester, so that will end up being absorbed by 115. But I don't think it was too crazy. Maybe the references and the stack frames get a little tough, but it's a lot of rapid-fire content that should be pretty easy to digest. Now that we're into the 116 content, the new stuff, the pace will start slowing down a little bit, and the content will be, of course, new. It'll be brand new concepts, starting with unit testing, brand new thing. So let's talk about unit testing. And the big question we want to ask and hopefully get close to answering: how do you know if your code's right? How do you know if it does what it's supposed to do? So you're on the job, you get an assignment, outside a lecture. You get an assignment, you write a bunch of code, you crank it all out, you're feeling good about it. How do you actually know that code does what it's supposed to do before you release it to your customers? So I mentioned last week, we've all used software. I'm sure you've used lots of software that has bugs in it. Even professional developers who've been doing this for years, they'll still release software with bugs. Software, as it turns out, it's pretty hard to write. It's tough stuff that we're doing here. So it's a very hard thing to do. This is a question that we don't fully have answered all across the industry. It's a very difficult thing. But let's at least make some progress on it and see how we can do the best that we can do to make sure that our code's as correct as we can get it before we release bugs to our users. So let's talk about the progression of testing. The very first thing that you kind of learn how to do, at least at UB, is just submit to AutoLab. If AutoLab's happy, I'm happy, right? So you write some code, you submit to AutoLab, or you write some code and you submit to UB Infinite, and you get results. It says, hey, your code's good, or hey, your code's bad. You'll get some information, some feedback based on what AutoLab says. This is a decent crutch while you're learning these concepts for the very first time. But even then, it has its issues. We have students who will submit to AutoLab hundreds of times. Some of you in this class will submit hundreds of times for an assignment and build a dependency on AutoLab, which we do have to wean you off of at some point. In 116, I don't worry too much about it. I kind of just let that happen. Next semester in 220 and 250, which is debatable whether I should or not. In 220, 250, depending on the instructor, they'll do different things. Some things they like to do is to just upload a partial grader that will only grade some of your assignment before the deadline. And then after the deadline, they upload the whole grader and then run the entire grader to get your actual score. But everything that's not on the partial grader, it's up to you to actually test on your own. And other instructors like to just limit the number of submissions that you can have. AutoLab has a feature. I can go in there and just limit the number of submissions. For your lecture questions, I use that feature. I just set it to 1. But that can be set. Some instructors like to set that and just limit the number of times you can submit. So there are ways that we're going to start weaning you off of this after 116. And some classes won't have auto graders at all. When I teach 312, I don't do any auto grading. You submit your code to AutoLab, but it doesn't grade anything. It's manually graded after the deadline. It's up to you to test your code and make sure it's right. And then, of course, after academia is gone, after you graduate and you go out there, get a job, and start writing code, getting paid to write code for a company, there's no auto grader. That's not going to exist. No senior dev is going to sit there and write an auto grader to test the code that you're going to write. If they're going to take the effort to do that, they're just going to write the code. There's no use for a developer who's dependent on AutoLab. So we do have to break your dependency of AutoLab by the time you graduate, or else we haven't done our jobs as instructors, because it's not going to exist outside of the classroom. So we do have to break your dependency on that. It's not going to exist. So you need to be able to test your own code without AutoLab, without anybody saying whether your code is correct or not. You need to convince yourself that your code is correct. So the first way that you started doing that, and hopefully you all got at least here in 115, is you call your code on specific inputs, you print the output to the screen, and you verify with your eyeballs whether it printed out the right thing or not. This is a fantastic way to start testing. It's a big challenge in 115 to get students to this point, to get you all to where you're at least calling your own methods, Some of you probably heard this in office hours where some students will sit down with their code and say, hey, TA, is this right? And the response should be, I don't know. Call your method and test it. Check it yourself. Write a main method. Well, not main methods in Python and JavaScript, but write some code to call your method and see if it's right. So hopefully you all got to that point. You're all in here in 116, so I assume that you probably all at least ran your code, printed to the screen, and verified if it printed the right thing. For 116, we want to get you to the next step of this progression and start automating those tests. So instead of printing to the screen and manually verifying whether your code is correct or not, we're going to automate that process through something called unit testing. So with unit testing, we're going to write a series of tests. We're going to write code that's going to test our other code. And we're going to write a sequence of tests that we're going to test our code with. This is a sequence of inputs. We're going to code an input and then call our method and expect the correct output and check if that output is correct. We're going to automate that whole process with code, and we're going to run those tests. And if our code passes all of those tests, we're going to say that the code passes, and the code's good. At least that test passed that code. And if a single test case fails, so on the set of inputs that we're testing, if on any one of those the code returned the wrong value, didn't return the value we expect, then that code fails. That code is not correct, and the test will say, you got a bug to fix. Then you have that information. You take that information, you go back to your code, you fix the bug, you run your test again, and hopefully you get all tests passing. But you want to test on all of your test cases when you automate this testing, which is the same thing with the main method. If you run your main method and print a bunch of stuff to the screen, and most of it looks good, but on one of the inputs, you got the wrong thing, you got some code to fix. You just got to go fix it. Not too big of a deal, but it's important to know that while you're writing the code and not while your end users who paid money for your software are using your code. Bless you. So let's go through a scenario. Now, I know I'll give the disclaimer right away. This code is stupid simple. Like, it's ridiculously simple. We know that this code is correct. We don't have to test this. But I want a really simple example for our first intro into unit testing so I can focus on unit testing without getting bogged down with the complexity of the code. So very, very, very simple method. We can just look at this and verify that it is correct. We don't need testing for this. But I want to use this example to show you how unit testing does work and something that you can verify yourself that it does work. So given this scenario, I give you a programming task. I say, programming task 2 is released. You have to write a method. Somebody's going to take this out of context. This isn't programming task 2. Your task is to write a method called add5 that takes an int as a parameter, adds 5 to that int, and returns that value as an int. Put it in a class called adder, submit it to AutoLab, and then you're good. So you write this code. You're feeling good about it, and you should. It's obviously correct. I'm not pulling any tricks on this one. How do you convince yourself that it absolutely is correct, though? How do you make sure this is correct? Well, you can submit to AutoLab and see what AutoLab says. You can write your main method, like hopefully you're all doing at this point. Hopefully you're all at this level of testing. Write a main method, call it a few times, verify with our eyeballs, and make sure that it does do the right thing. And we got some work to do. It's not too much, but we have some mental effort to put in. Okay, 7, that was the first one, so it's the first line here. 2 plus 5 is 7. 5 plus 5 is 10. That's the 10. 1 plus 5 is 6. That's 6. Okay, so we're good on these 3 tests. It takes a couple of seconds, but it takes a little bit of time to look through those and manually verify. But what happens when the code is more complex than just plus 5? What happens when you have a task that's asking you to sort hundreds of songs by either artist or title, and you have a test case with 100 songs, you print them to the screen, and you're looking through hundreds of songs and making sure that every song in that sequence is in alphabetical order. You're checking the song title, and some song titles are like the same up until character 6. You got to scan all those characters for every single consecutive pair. This is going to take a bit longer. It's not a matter of seconds anymore. It takes a long time to verify that your sorting method is doing exactly what it's supposed to be doing. on all inputs. It's going to be very tough to manually verify when you're putting a lot of stuff to the screen. I've seen some of the auto graders for 115 where you get tons and tons of text. Imagine scanning through all of that and manually verifying that every one of those test cases was actually correct, that you got the correct output by hand, no automation, and just manually verified. So this is fine for very simple methods. We can get away with it here. But once our code gets more complex, we need to automate this, or else we're going to drive ourselves nuts and do nothing but testing for the rest of our careers. We don't want to do that. So we're going to unit test this thing. Let's see our first unit test suite. I'm going to do that way too much. I used to call these test suites when we were teaching in Scala. It's going to take my brain a bit to adjust. I'm going to call them test classes because it is a class that defines the tests in Java. So let's take a look at our first test class, which is going to be in a separate file from the code that we're testing. So we're creating a separate test class, and that's going to test the code that we're testing. I might be getting a little ahead of this, but for your homework, you will need an import statement and import the code that you're testing. The difference is these two classes are defined in the same package. Any two classes defined in the same package don't have to import each other. They're automatically imported, everything in the same package as that code. For your homework, test problem set and problem set are in two different packages, so you do have to import problem set, which I believe is there in the handout code. If it's not, I meant for it to be there. It should be there, your import in the handout code, just so it's one less thing you have to think about. So let's go through this code. Let's break it down. The very first thing, we need to import the library that we're using. So we're using JUnit, which is a library. A library, if you haven't used that term, I think they use that in 115. It's just a bunch of code that we didn't write. And this is what we call an external library. So we do have to import this just like ArrayList and HashMap. But unlike ArrayList and HashMap, JUnit is not included in Java. JUnit does not just come with Java. It's not pre-installed. It's not there. It has to be downloaded, linked to your project before it's available, and then you can import it. If it's not downloaded and part of your project, the import statement is going to have an error. It's going to say, you can't import this. I don't know what this is. It doesn't exist. Luckily, IntelliJ and the way the project's set up makes this automatic for you. So again, one thing that you don't have to worry about is when you clone either the examples repo or the project code, you're going to see a file called pom.xml in there. And that, among a few other things, pom.xml defines your dependencies, which are your external libraries that need to be downloaded. And you'll see JUnit in a block of XML. JUnit will be there. When you clone the repo, when you download it from GitHub, IntelliJ looks at the code and says, oh, pom.xml. I know what to do with that. Looks like I need to download JUnit. So when you clone the project, one of those progress bars that you see at the bottom of IntelliJ is downloading JUnit and linking it to your project so you can import it. So this all happens automatic the way things are set up. But if you're starting your own project, you go to File, New Project, and you start a brand new project and you try writing test cases because you're all going to use test cases even when you don't have to, yeah, right? You try writing JUnit test cases, you're going to get errors because you don't have that pom.xml. It's as easy as copying that pom.xml into your new project. And then sometimes you have to right-click the pom and say Add as Maven Project. But that pom, if that's not there, or you don't install JUnit by some other means, it's just not going to work for you. But everything for this course should just work automatically for you. If it doesn't, let me or the TAs know. We'll get it straightened out. It should. I haven't seen this issue yet this semester. I haven't seen that issue in years, actually. It's just been set up the right way. But switching to Java, there's a possibility that someone will run into an issue. Just let me know. And our next import, we're going to import a method. This is a new style of import we haven't seen, which we won't see too much, probably just with testing. But we have an import static. Now, this is a little bit different than a regular import. So instead of importing a class, we're importing from the assert class. We could just do import org.junit.assert, and it'd be just like any other import statement. But assert has a static method in it it has a lot of them, but it has one in particular that we're interested in, and that's assertTrue. So by doing a static import, we're importing one static method from the class. So we're saying, I'm not interested in the entire assert class. I just want this one static method, and I want to call that method in my code. So we're going to import just the assertTrue static method from this class. And then we can just call assertTrue, as we'll see later in the code. If we just did import org.junit.assert, it's not that big of a deal. It still works. Just instead of assertTrue, you would have to type assert.assertTrue. So importing just the method cuts down some of the typing that we have to do. That's all. It's nothing too crazy, nothing too magical. If you're afraid of that static keyword up there, just import the whole class and say assert.assertTrue, and that'd be fine. I don't think this is too big of a deal for anyone, though. And to be perfectly honest, I didn't even realize that this was a static import until I was making these slides. I've written so much JUnit code, I never noticed that it was a static import until last night when I started making these things. I'm like, static import? Why is it doing that? Oh, it's importing just the method. So it's not something you really have to think about. That's how much I've thought about it throughout my whole career. 0. But I wanted to point that out, of what that is, because it's on a slide. It can be confusing. And then we're going to write methods that are going to be our tests, where we're actually going to test our code. Notice that this is not that's my next slide, right? Notice that this is not a static method. I'll get ahead of my slides a little bit. Oh, no, it is on my slide. I'm going crazy. So notice that this is not a static method. This is just a regular method. We don't have to worry too much about the difference between the two just yet. We'll worry about the difference on Monday. We'll get to static. It's been foreshadowed a lot, and it'll be foreshadowed right now. But this is not a static method. If you put the word static right here, things are going to break. It's not going to be a test class anymore. It's not going to be a test method. It's just not going to work. This has to not be static. That's the way JUnit, the library we're working with, works. It needs to be a non-static method. And every method that's going to be a test, you have to annotate with this @test annotation. In fact, this is what we imported up here. There's no like importing the entire library or anything. We're just importing that annotation so we can use that annotation to say, hey, JUnit, this is a test. I want this to run as a test, and I expect it to be testing my code. Without that @test, doesn't work. So JUnit needs this method to be public void, and then whatever you name it, and it needs the @test annotation. If you do those two things, JUnit's happy. JUnit's going to run this as a test. But that's JUnit's interface. It needs those things to be able to do its thing. Don't forget the @test annotation. There have been a decent number of students in the class who have been getting ahead of things and starting this homework before this lecture, before they knew how to do the testing. And among those students, this was by far the most common question that we've got is, why doesn't this work? With the answer being, that's always the most common question. But the most common answer was, you forgot your @test annotation. Even a few TAs did this when they were testing the assignments. You have to have that @test annotation. So make sure you have that there to mark this as a test that you want JUnit to run. Don't forget it. Very common mistake that we've seen already. And then your method name. You can name your test whatever you want. Nowhere in the homework documents will it ever say, write a test named this. And this is just a method, so whatever method names you want to have. But the method name will match the name of the test. This will be important in the AutoLab feedback. It will give feedback on each of your specific tests. Right here, we only have one test in this test class, so this will make a little more sense later. But AutoLab will give you different feedback on each of your tests that you have, each method annotated with the test annotation. I recommend naming these something meaningful. A lot of you won't. That's fine. I'm not going to stop you. But I recommend naming these something meaningful to make some use out of that feedback to help your debug process. And finally, we're ready to actually test code. So let's test some code. So inside the method, the body of the method is going to be where we're going to put our tests, and we're going to use this assertTrue method to be able to tell JUnit that this is something we want to test. So we're going to do the same thing that we did in the main method. We're going to call our method, but we're going to automate the result and say, I expect this call of add 5 of 2 to result in 7. So we're going to use assertTrue, which is a method that takes one argument, which is going to be a Boolean expression. So this takes a Boolean expression, and we expect it to be true. We're asserting that this is true. I expect this Boolean expression to resolve to true. AssertTrue is going to check that for you. This is the only assert method I'm going to show in lecture. There are a lot of other assert methods. You're welcome to go explore that on your own if you want to read the documentation, use assert equals or assert false, assert null, whatever else you want to do. I'm only going to show assert true because I want to show you how to write your own Boolean expressions and how to compare things in ways that the library would just do for you. I want to crack that open and show you this is how you actually test your code. I don't see a lot of use in just saying, call this method, it does it for you. Because it doesn't let you see enough computer science. That sentence kind of got away from me. But I want to show you computer science. I want to show you how things work. I don't just want to say, oh, call this method, it'll do it for you. You don't have to think about the details. So we're just going to show assert true. Paul and I are only going to show assert true. Your code was working even without the at tests. I'd have to look at that. It shouldn't run in JUnit is the issue. So if you have a main method and no at tests, then it would run the main method still. But I have to see that code to see why that works without the test annotation. If it does run without tests and runs as a test suite, that'd be really interesting. I'd want to see that. So then I might have to update some auto-grading code. So if any of these three tests, so assert true, we're going to say this Boolean expression, I expect it to be true, it better be true. We're going to call the method. We expect this to be 7. This should result to 7. And we're going to turn this into a Boolean expression. If that equals 7, then this will resolve to true. And it'll be assert true of true. And that test case will pass. If any of these Boolean expressions resolve to false, then that test case will fail. And then the entire test fails. And the entire test class fails. You have to pass every single one of these. And the suit observers might say, hey, where's your main method? I don't have any main method in this class. The way JUnit and IntelliJ are set up, so JUnit has a testRunner. It has a main method. And when that class is run, you can run that with a test class, and it'll run that test class and give you your run your tests in that test class. IntelliJ makes this really convenient. It just gives you a go button right in this class. That go button's a bit of a shortcut. It does mean it's going to go invoke JUnit's main method, and that main method is going to consume your code here and then use it and run your tests. So we are still running a main method. Every Java program starts with a main method, but it's obfuscated. It is behind the scenes a bit. JUnit is running the main method and consuming our code. Why is the testing method not static? So I'll give a little bit more detail on this since we got a question. So this is not a static method, meaning that we have to create an instance of this class in order to run this code. And that's the short answer is that's the way JUnit works. So JUnit, when the testRunner is ran, it's going to create an instance of this class or an object of type add test, and then call the methods through that object. When code is used in that way, it's non-static methods. Static methods are only if you're calling the method directly without creating an object. If that doesn't make a lot of sense, don't worry. Monday we're diving headfirst into that discussion that so far I've been avoiding. We're going to dive headfirst into it on Monday. So if you have multiple tests, and we'll see that in a little bit, if you have multiple tests in your test class, then you'll get feedback on each one of them, both in IntelliJ and in AutoLab. It'll show you which of the tests passed and which of the tests failed. but you won't necessarily get feedback on your individual test cases. So if you split your test cases into multiple tests, you know what, let me get to it on the slides. It'll give you more feedback, which will help your debug process a lot more. So let's revisit our question. How do we know if our code is correct? Well, now our question becomes, is this enough unit testing? We got 3 test cases. If I have code, say we can't see the code on the right, we just know that there's code that we're testing, and it passes this test suite. It passes these 3 test cases, gets the right output for these inputs. Are we confident that that code must be correct? Is it correct on all inputs if it's correct on these 3 inputs? How confident are we in that? And that's a question that we have to constantly ask. At this point, I think it's pretty easy to answer that question right now. No, these 3 test cases isn't enough. I hope nobody's comfortable with just these 3 test cases, assuming you can't see the code. You're comfortable because you can see the code, and you just obviously know it's right. You're just adding 5. But what if somebody's doing something fancy with this method? Instead of using the addition method with decimal arithmetic, what if they want to optimize this and they start getting a lot of fancy Boolean expressions in here and start working on the bit level to do this add 5? Now the code might get really complex, and we won't be immediately confident that it is correct. We want to do some more testing to make sure that that person who's trying to shave a couple nanoseconds off their runtime, making sure that they still have the correct output. Efficiency is terrible if it's incorrect. So let's add some more. The big problem with these is we have 3 positive small integers. That's one type of test case. And I would say that this is what I would call common test cases for this example. If you're adding 5 to a number, we can kind of expect a lot of the inputs, depending on the specific application. But in general, I would expect a lot of the inputs to be probably small integers. That's what people are going to give me the most. That's what this method's going to be used for the most. So we want to test the common cases. This is just standard usage of the method. I also want to test the uncommon cases. For this purpose, I'd say these are the negative numbers. I want to make sure that this works on negatives. If I don't have any test cases with negative numbers, I'm not feeling good about this code. Again, assuming that I can't see the code. I want to be confident enough that any code that passes my test suite, I'm confident that it is correct without ever even having to see the code. That's where I want to be with my test cases. Without negative numbers, I'm not comfortable with it at all. So let's get some negative numbers. Especially -5, this is a good input with the result of 0. There's possible somebody doing some fancy binary arithmetic, maybe they missed that edge case where the result is 0. Missed that case where the output's 0. I spoiled the next slide, but it's fine. And we want to, so these are more unusual, uncommon inputs. We might not get them all the time, but they're going to happen. Some user is going to have these as inputs to our code. We want to make sure we're going to run just fine when we get those inputs. So we want to test those. And in general, we want to think of any test case that's going to expose a bug, any bug that we can think of. So I can think of a bug when I think, a method that adds 5 might break on negative numbers. So I think of that bug, I write some test cases. Yeah. Yes. Oh, actually, I did want to mention that. Thank you. So I broke this into 2 separate tests. When I was talking about the test name, you'll get feedback in AutoLab with your test name. I have multiple tests in the same test class. Each test has multiple test cases. You can put them all in the same test, the same method. I recommend breaking them up, though, that if you have these more broken apart, you can make use of the feedback better. And it's just generally good practice. I'm trying to encourage that with the AutoLab feedback for transparency. But now we have 2 tests each with multiple test cases. And when we run our tests, if one of these fails and one passes, we'll get that information. We'll know to just focus on the test cases for the failing test. If we have them all in one test, it'll just say, the test failed. And that doesn't help you in your debug process as much as it could if you broke them into separate test cases. Because the goal of testing is to expose any possible bugs that might exist. So anything you can do to give yourself more information when a bug is found it's going to shorten your debug cycle so you can find and eradicate that bug quicker. So anything that helps do that is going to save you time in the long run. Those are good things. We want to save time. And there's one more case. I would not be comfortable with my test suite, again, assuming if I can't see the code. I wouldn't be comfortable with my test suite unless, oh, I did have a slide on it. I would have got there. Unless I test the edge cases as well. For this example, it's not even really an edge case, but it could be, again, if somebody's getting fancy with their binary, is 0 as an input. This is a common edge case. These are the strange situations, the ones you might get every once in a while, but not often. Maybe with live users, maybe after 1 million uses of this method, somebody finds that edge case, gives you that input, and potentially breaks your code if you're not testing for the edge case. These are commonly 0, empty string, empty array, empty hash map. This is a good starting spot, those 4, depending on what your input type is. Those are the good starting points for edge cases. What happens when I have no data? It's very easy to write bugs with this as the case. For like your min method in 1.15, a lot of students like to say, instead of initializing, you want to initialize your min value. Say you have an array of ints, you want to find the min value. A lot of you like to say min equals array of 0, and then go through your loop and make sure, and then update your min as you go through the loop, right? Nothing necessarily wrong with that. But what happens when you get an empty data structure and you're trying to access the element at index 0, which doesn't exist, and you get index out of bounds? We want to test for those edge cases and make sure we don't have those bugs. If you initialize your initial min properly, you're not going to expose that bug. You're going to be fine on that edge case. And if you do want to initialize the way I said, just have a conditional. If the thing's empty, return whatever we return in our failure state. Else, initialize to the first element and go through my loop. So those are good edge cases to check. And like empty string, this is a common one in web applications. You have a page that's just register your username. Give me your username and your password twice. And somebody's username that they enter is the empty string. Your code has to not break. You're not going to create a user with the username empty string. You have to handle that gracefully, so it's something you want to test for. What happens when somebody gives me the empty string as an input? Users do this all the time, so it's not necessarily even an edge case. It's not a rare case. Edge cases are sometimes not rare. Users will constantly submit with empty string in web apps, just all the time. I don't know why, but they do. And so your goal, like I said, is to think of any possible bug and write a test case for it. And if you're unsure, just write lots of test cases. Write lots and lots of test cases. You can't have too many test cases. Just write more. If you're unsure, write more. This is what AutoLab will say sometimes. AutoLab will say, write more tests. And you come to AutoLab and say, what does this mean? And me and the TAs will be like, write more tests. It means you got to write more tests. You need more testing. It's common office hour interaction. You need more tests. When we say need more tests, we don't always necessarily mean just add more tests. You tend to get a lot more mileage off of adding a variety of tests. Adding 4 tests that are very different from each other is much, much more effective than having 100 tests that are all testing the same thing. So in this example, a student might come to office hours with 100 tests, all testing small positive integers from 1 to 500, just a whole bunch of random numbers from 1 to 500. They'll have 100 tests, and I'll say, you need more tests. I have 100. What do you want, 101? But if somebody comes to office hours with maybe two tests with small positive numbers, 2 tests with small negative numbers, and a test with 0, they might not even be in office hours because AutoLab probably said you're good if you have a nice variety of tests. And we could even add more variety to this. I don't have any inputs, like over 1 million. I would want to test the very large positive inputs, the very large negative inputs. So we can even add more variety here. But variety of testing is, you're going to get a lot more mileage out of it than just more tests. Like we could test all the integers from 1 to 1 billion, and the code might fail on -1. So variety of tests And that's going to get your incorrect solutions out. Well, a lot of you might not haven't submitted to AutoLab yet. But your incorrect solutions, you'll get them out of there with a variety of testing. So let's see this in action. So here's the code that we're testing. Not very interesting. We can run it, see the main method, and verify with our eyeballs. Okay, 7, 10, 6, that's what we expected. Cool. But we want our automated testing. When you run your tests, these are the same tests that we just saw in the slides. And you're going to get the go arrows for each test. Don't make the mistake of running just one test. You want to run all 3 tests here. So make sure you get up to the class, or right-click on the class over here and go to run. And when you run your tests, you're feeling good if you see some feedback like this. I got 3 green check marks. I can see my 3 tests running, and all 3 of them passed. When they pass, you don't really get much information. They passed. What more do you need? You're feeling good about it. When a test fails, let's say instead of adding 5, we added 4. We have incorrect code now, an incorrect solution. Our test should identify this and say, yo, that's wrong, and fail. So we run this, and this is what we're going to see when our tests fail. We're going to see this X. We're going to see all kinds of red text. And we're going to get as much information as JUnit really can provide for us. And we didn't provide much. We said assert true, and the true ended up being false. Instead of true, we got false. So we got assertion error. The assertion failed. We can click on this blue text and see what test case failed. We see the very first one failed. And when a test case fails, whenever an assert is false, the test ends. That's it. JUnit doesn't even move on. The other tests in this method don't even run. The other test cases in this test don't even run. So these last 4 never even ran. The first one here ran, the next ones didn't. First one ran, and then with the last test, there's only one test, and it failed. So not much going on there. So let's fix our code. Whenever you see tests failing, you want to go to your code and fix your code. Let's break a test case. Instead of correctly expecting 105, what if our test was incorrect? Which will happen a lot if your feedback in AutoLab is your test failed a correct solution. What this means is at least one of your test cases isn't testing the correct expected output. So here we see that we've passed 2 tests, but we see the problem one is this add 5. And when we go to the line, it's going to take us right to the last test case. So that we can deduct that the first 4 test cases are fine. We passed all 4 of those. But when we got to the 5th one, things went downhill here. So we know exactly where to look. We're going to look right here and say, oh, 100 plus 5 isn't 104. What the hell am I doing? And then we can update this to a 105. And get back to what we like to see, a whole bunch of green check marks. So once you write, you're going to sit down, write a nice test suite with all the test cases for all the specific bugs you can think of, and just add a lot of tests. And then go and write your code. And each time you're editing your code, you're feeling okay about it. You think it might be good to go. Run your tests. And if any tests fail, you update your code. Keep doing that process. Keep going through that cycle until you get your check marks, and then you're feeling good. Then you can submit to AutoLab and see what AutoLab says, and hopefully AutoLab says you're good, and then done with that task. A lot of times, as you'll find out, AutoLab will say you're not good, and then there's a lot more to the process, but we'll get you all through that. So there are a few things that we need to test specifically. Any questions, by the way? I haven't stopped at all this lecture. Let me catch up on chat, too. I didn't get through the slides in the previous lecture, so I'm going to stop before the testing doubles, if you're following along with the slides. We'll do testing doubles tomorrow. Yeah, the input type is... So some methods don't have any inputs. So this method doesn't have any parameters. Your tests shouldn't have any parameters to them. And when you don't have any parameters, you still have to have a parameter list, but you just have open paren, close paren. then since there are no parameters, there's nothing to give a type to. There's no types there because there's no variables. And print the first parameter string. Yes. So that's one of the next things we're going to talk about in this demo. So here we're going to see I'm going to have a second argument here when we call assertTrue, and I'll talk about that exactly. So the first example, I left that out just to keep the first example as simple as possible. Let's get to some more, a little more complex stuff at this point. So here's a test suite. This is in the repo. You can run it yourself. I meant to do it while I was in IntelliJ. Again, I forgot 2 lectures in a row. But you can verify this fails. Doing the same exact thing 2 times. AB space dot strip. Dot strip is going to remove any leading and trailing white space. So str1 and str2 both have the characters AB. They're the same string according to us human beings. The computer disagrees and says false. These are not the same. str1 equal str2 resolves to false, and this test fails. The big lesson here is never use equal to compare 2 strings. You can't use equal to compare strings. What equal does is checks 2 values to see if they have the same reference, which is, are they referring to the same object on the heap? And the short explanation for this is strings are weird. Strings are just weird in Java. The longer answer is any type that starts with a capital letter is a non-primitive, which means it is an object of a class, and it does go on the heap. Only primitive values go on the stack and are passed by value. Everything else is passed by reference and stored by reference. Now, when we get to memory diagrams with strings, we've avoided strings in memory diagrams so far. We actually have. No, we did put strings on the stack so far. But when we put strings in our memory diagrams, we will incorrectly put them on the stack and treat them as primitives because they behave like primitives. But in reality, they're wonky. They're static values, so they can't change. And Java will do a lot of optimization to sometimes have these references refer to the same object on the heap, and sometimes they won't. If you do the same example without the dot strip, it'll return true and the test will pass. So sometimes Java refers to the same string on the heap, sometimes it doesn't. There's a lot of complexity that goes into how Java manages its static strings, these static values. For our purposes, use dot equals. Dot equals instead of equal. In general, whenever we're testing 2 non-primitive values, we're always going to use either dot equals or some extra code. Sometimes if we're comparing 2 arrays, we might loop through those arrays and compare the values independently. Sometimes we can get away with dot equals. But in general, and especially for strings, you have to use dot equals to compare those strings. Sometimes you'll get away with equal, sometimes you won't. You're just rolling the dice if you use equal. To be safe, just never use it. Don't compare strings with equal. You're going to use dot equals, and that's going to actually check the values of the string and not the references. Not checking if the references referred to the same string on the heap. It's going to check, are these strings actually the same sequence of characters? I changed the example, but this works with the dot strip example as well. With the dot strip example, it'll say, okay, they both start with A. Okay, they're both B. Okay, we hit the end of both strings. We're good. Dot equals will do that. Equal will not. And I also snuck in a second argument to the assertTrue method. So when I called assertTrue here, I'm not just giving it a Boolean expression now. I'm giving it a string and then a Boolean expression. This is another recommended, but those of you who won't do this, I'm not going to hold it against you. Unless you come to ask me questions in office hours, I'll be like, I told you how to avoid this. Maybe not, I don't know. But depends on the situation. But if I'm given a string and a Boolean expression, this is going to give me more feedback if the test case fails. So if the Boolean expression is true and the test case passes, everything's the same, nothing happens, we never see the string, and we get a green check mark and we're feeling good, as long as all test cases in the test pass. If the test fails, so if this Let me go back to one that does fail. So this one fails. This is false. This evaluates to false. When a test case fails, JUnit is going to show you your string, which we call a hint text, or JUnit just calls a message. But I like calling them hint text. This is your hint. This is your clue as to what went wrong. So you can put any information here that you want that's going to help you debug if the test case fails. Now, this hint string isn't very useful. This is just the first example of that you can put a string there. This test case fails and it says strings equal. I don't know what to check when I see that. But this is what this test case will say. It'll say strings equal when this test case fails. So this can really provide help if you put a more useful string here, which we will in the next example, where when your test case fails, you get some information that speeds up, that expedites your debug process so you spend less time debugging your code. That's what we want. That's ultimately the goal. We want to not just write great software, but not waste our time while we do it as much as we can, as much as we can help it. So let's revisit this letter example. We had this method last week, where we gave it a number, and it said whether you got an A, B, C, D, or F. And it just checked the tens digit and figured that out. So let's add more granularity to that. Let's add pluses and minuses to this example, and write a method that's going to take the value and say whether your grade should be a plus, neutral, what do we even call those, or a minus. So if your ones digit is greater than or equal to 7, so if you got a 7, 8, or 9, you're going to get a plus. If it's a 3, 4, 5, or 6, you're not going to get a modifier at all. And if it's a 0, 1, or 2, you'll get a minus modifier on your grade. So we can see in the B range what this is going to do, what we expect it to do. Of course, we want to test. And to start, we would just write our main method, give it a few inputs, and make sure we get our pluses and minuses. And here we're going to have more meaningful hint text. We're going to test our method. We're going to call it, store the value that's returned. And for each input, we're going to say, okay, we called down 95, and we expect a no, plus, or minus. But if this evaluates to false, and we're using our dot equals because it's strings, if this didn't equal the empty string, if this evaluated to false, tell me what it did evaluate to. And this is where the hint text gets a lot more useful. Tell me what I actually got. It's not enough to just say my test case failed. I want to know, I know what I expected, but tell me what I actually got. And that's going to help us debug things. So that's a better use of hint text. For 95, I expect nothing. For 78, I expect a plus. For 51, I expect a minus. We run on these 3 test cases, and we're like, yes, our code's right. We're done. No, and we actually are done. But when we have a test case of 100, guess what? My student just got an A minus. We got to add more test cases. Our edge case in this case was 100. We got to make sure we test that, fix that, and then we're feeling better.